All right, in this next example, we're going to be asked to form the polynomial function whose real zeros are -4, 0, and 2, and has degree 3, and, should have a comma there, goes through this point 1, 15. Okay, well, to form that, notice that I said form the polynomial. There's only going to be one. Okay, this extra point that we're referring to here is going to limit the or restrict what our leading coefficient can be. Okay, so to start this off, I would take each of these three real zeros and make them into factors, right? So I would definitely have, let's see, x minus -4, x minus 0, and x minus 2. Now when you've done a few of these, you may just simplify it without writing it out like this. The double negative will make that a plus, so you're always going to use the opposite sign of what you have on the 0 there. 0 itself, well, x minus 0 is simply x, and we have x minus 2. Now generally speaking, we'll move the single x out in front. So we have x times x plus 4 times x minus 2. Now these are the three polynomial factors, linear factors I should say. But we could also have a leading coefficient, and we need to figure out what that leading coefficient is going to be. I'll call it a sub 3 because we're dealing with the degree 3 polynomial. Now I'm going to write this as y equals, you could make it function notation, f of x, whatever you want. But the point 1, 15 must satisfy this equation. And so if I were to plug in the 1 for the x's, the 15 for the y, and solve for the unknown a3, I will get a single value, and then I can use that as my leading coefficient. So let's look at 15 equals a sub 3. Now the x becomes 1 times 1. 1 plus 4 becomes 5. 1 minus 2, I'm just plugging in 1 for all of the x's, right? 1 here, 1 plus 4 is 5, 1 minus 2 is -1. What I end up with is 15 equals a sub 3 times -5. Well, I can divide out the -5 from the 15, and we will see that a sub 3 would have to be -3. Okay? So now my final answer has to incorporate all this stuff. I have to put the leading coefficient back into my factored form. And so my final polynomial, we'll call it f of x, is going to be -3x, right? -3 times x, x plus 4, and times x minus 2. All right? At this point, I would consider this problem done. There's really no need to expand this further. Especially when you start getting to larger degrees. If I ask you to do a degree 5 or degree 6, you're not going to want to expand this out. So I would accept answers in factored form.